Emhart Glass is a proud supplier of refractory expendable parts for the container glass industry. Their feeder refractories, such as spouts, tubes and plungers, are known the world over for their quality and reliability. The conditions inside of the feeder bowl of a glass forehalf are brutal. At temperatures of about 1200 degrees Celsius or 2200 degrees Fahrenheit, in the constant presence of molten glass, the wear experienced by these refractory shapes requires regular replacement. Spout removal. A spout is commonly changed on an annual basis. To prepare for the spout change, a dam must be placed in front of the spout to stem the flow of glass. Once the remaining glass in the spout has been allowed to drain completely, the spout burners are turned off and the entire feeder is allowed to cool. To speed this process, the orifice ring, tube, plungers and spout covers are removed. Once the spout is cool enough to handle, approximately 200 to 300 degrees Celsius, the spout burners are removed. After checking that the fuel is turned off, use an Allen wrench and a rubber mallet. Loosen the retainer bolts and remove the burners from the burner manifold. Next, remove the bolts that attach the burner manifold to the spout casing. And disconnect the premix fuel line. Now the burner manifold can be removed and set aside. The spout burner blocks are now ready to be removed. Care must be exercised to minimize damage to the burner blocks. The blocks should be inspected thoroughly for cracks or chips and should be replaced as needed. Using hammers and pry bars, the old spout is broken out of the casing and disposed of. The backup insulation, which in this case is made up of insulation panels and an insulating castable named MCAST 25, is also removed and disposed of. Any mortar residue must be removed from the face of the equalizing channel so that the new spout can be properly sealed. Remove any remaining material from the spout adapter ring and replace it in the spout casing. It is important for this area to be free of debris so that the new spout can be properly installed. New spout installation. New insulation panels are fit into the spout casing as the first of 2 layers of backup spout insulation. Now the new spout can be lowered into place, inside the spout casing. Care is taken to ensure that the new spout sits properly in the adapter ring and is level with the spout casing. It is essential that care is exercised to ensure that the spout is completely level. Wooden shims are put in between the new spout and the equalizing channel to achieve the desired 1/2 inch mortar joint. It is essential to maintain a consistent 1/2 inch spacing between the spout and the equalizing channel block. Spout luting cement is then mixed with water to the desired consistency and used to fill the joint between the spout and the channel. Once the luting cement has been allowed to dry and harden, the second layer of backup insulation is installed. The most common material for this purpose is Celotom and MCAST 25. Celotom is a dry, granular powder which must be densely packed into the cavity between the casing and the spout. This is a proven method used throughout the world for many years. However, it is time-consuming and prone to incomplete filling underneath the spout. MCAST 25 is the material employed for this demonstration. This is the preferred material developed by Emhart Glass Manufacturing in order to address the disadvantages of Celotom. MCAST 25 is a lightweight, insulating castable material. It is combined with water at a ratio of 1:1 by weight and mixed for 5 minutes. The castable is then poured into the cavity between the spout and the insulation panels. In order to ensure that the space underneath the spout is completely filled, the MCAST 25 should be poured on only one side of the spout until it can be seen flowing out on the opposite side. At that point, the remainder of the cavity should be filled to the top of the spout refractory and finished to a smooth surface. The MCAST 25 must be allowed to set or harden before moving on with the spout installation. This generally takes between 1 and 2 hours. With the MCAST 25 firm to the touch, a small amount of mortar is placed on top of the MCAST 25 to provide a flat, level surface for the burner blocks to set. The burner blocks are then put into place and checked to ensure that they are level with the spout. A small amount of mortar is then placed in the joints between the burner blocks. The spout burner manifold is bolted in place. The spout burners are placed back into the manifold with new gaskets and aligned with the burner blocks. The retainer bolts are then tightened. The fuel line is reconnected and tightened. The rear spout cover block is put into place. Tube installation. A new tube is put into the holder and the bolts are hand tightened until they are snug. As the tube is heated, the thermal expansion of the tube will cause the bolts to tighten. If these bolts are over-tightened while the tube is cold, it can cause the tube to crack and break around the flange area upon heating. Over-tightening at this stage can also lead to stress cracks which may not present themselves until later in service, be it days, weeks, or months. The tube is lifted into place and the front spout covers are installed. Now the insulation retainers are installed into the tube and the plungers are positioned. Orifice ring installation. The orifice ring should be prepared prior to beginning the spout change. This is done by placing the orifice ring in a metal pan and insulating around it. As with the spout, the two most common materials for this purpose are Celotom and MCAST 25. To prepare the orifice ring, first the new ring is placed in the pan and secured. This prevents the orifice ring from moving around when the insulation is added. In this demonstration, the cavity between the orifice ring and the pan is filled with dry Celotom insulation. The material must be packed tightly to ensure that there are no voids underneath the ring. This is a time-consuming process that requires skill and experience to be performed correctly. Here, MCAST 25 is used to insulate the orifice ring. This is the preferred method of insulation. The new ring must again be secured to the pan. The insulating castable is then mixed with water at a ratio of 1:1 by weight and mixed for 5 minutes. The castable is then poured into the cavity between the ring and the pan. Once the cavity is completely filled, the castable must be allowed to set or harden for approximately 1 hour. Emhart Glass offers a hard gasket system to properly seal the orifice ring to the spout. This system consists of 2 pre-cut gaskets, a soft gasket made of ceramic fiber blanket and a hard gasket made of ceramic fiber board. The soft gasket is first positioned on the ring and the hard gasket is placed on top. Here, the gaskets are secured in place with masking tape. After installation, the molten glass will quickly burn away the tape without any adverse effects. The prepared orifice rings should be kept in an oven until they are ready to be installed to ensure that they are completely free of moisture. Before installing the prepared orifice ring, the surface of the spout must first be prepared. Anti-adhesive cement is mixed with water to form a thin solution. This anti-adhesive mixture is painted onto the underside of the spout, on the surface where the orifice ring will be fixed. A thin layer is also applied to the orifice ring gasket. This anti-adhesive coating will serve to ease in the removal of the orifice ring gasket at the end of its service life. After this coating has dried, the orifice ring is positioned under the spout and clamped into place. With all components of the spout fully installed, the installation is complete. Although not covered in this demonstration, the next step is to gradually preheat the spout using portable burners to a temperature of about 800 degrees Celsius before the spout burners can be lit. With the spout burners lit, the spout continues to heat gradually until the desired operating temperature is reached. Once at temperature, the dam is removed and molten glass fills the spout, allowing the plant to return to normal production.